This is the eutectoid. Okay. This is the eutectoid. Okay, did I say eutectic? It's not eutectic, it's eutectoid. One solid phase turning into two other solid phases upon cooling. This is the eutectoid reaction. So eutectic reaction is not shown here. So any peritectic reaction? Liquid plus solid converting into a solid. Is there any peritectic reaction here?
सर
Okay,
3
not.
है सर.
Okay. ये कौन से हैं?
सर एक ऊपर वाले सर गेमा प्लस एल, फिर एक नीचे उसके डेल्टा प्लस एल और फिर एप्सिलॉन प्लस एल.
ओके, कौन कौन सा है?
सर एक सर सबसे ऊपर वाला है गेमा प्लस एल, फिर उसके बाद सर एक है डेल्टा प्लस एल, और फिर एक सर है एप्सिलॉन प्लस एल उसके नीचे सर.
एप्सिलॉन बस. ओके, उसके नीचे तो मैं नजर नहीं आ रहा. बट ऑब्वियसली here this is going into eta and here this is gamma plus liquid going into delta. ठीक है. So we have these two. Okay, then we come to congruent transformations. So no change. Congruent transformation means no change in composition upon phase transformation. So looking at this phase transformation, do you recognize any phase where there is no change in composition upon phase transformation? कहाँ पे जो है वो नहीं है? कोई ऐसी composition है where there is no phase, there is no composition change upon phase transformation, either heating or cooling. Do you recognize any composition? Noman?
Yes, sir.
Which composition does not change upon phase transformation? इस पे जो है वो बता दें कहाँ पे है. बहुत से पॉइंट्स हैं, you can name any point or a line.
जिस पे चेंज नहीं हुआ है
इस पे composition change नहीं हो रही.
सर ये जो 80% वेट
80 पर जो ऊपर लाइन वर्टिकल लाइन है सर.
अच्छा, इस पे चेंज नहीं हो रही. So this is a okay. On this line there is a congruent transformation.
सर इस पे चेंज नहीं हो रही कंपोजिशन.
Okay, ठीक है. And what about pure elements?
20%
transformation पे change नहीं होगी. Okay, but those are pure elements. So this is some phase inside this diagram, some particular composition of two different constituents or metals that is undergoing a transformation where there is a no change in composition. ऐसा ही है.
Yes, sir.
So phase transformation where at least one of the phases go through composition change, वो कौन सी? Can you point? Can you say point to a line or point to a field or point to a point? Okay, so any guesses? Incongruent transformation कहाँ पे हो रही है? यही है.
सर गेस सर इतना आइडिया नहीं है सर.
Zuhair, are you there?
Yes, sir.
Incongruent कहाँ पे हो रही है? Any other person would like to say anything?
सर जहाँ पर ये जो कंपाउंड बन रहा है सर, इसके भी तो मतलब राइट और लेफ्ट पे, मतलब अगर हम कुछ ना कुछ भी कंपोजिशन चेंज करते हैं तो
ओके,
फेस
सो
चेंज हो सकते हैं सर।
ओके, लीविंग दिस कंपोजिशन, अगर आप इस तरफ भी आ जाएं, इधर भी आ जाएं, so that involves a composition change other than this line or pure elements. ठीक है, every other composition, either going through this route, going through this route, or through this route, that involves a composition change in composition upon phase transformation. ठीक है, अगर यहाँ पे भी देखें तो लिक्विड में तो सॉल्युबल, लेकिन जब ये ट्रांसफॉर्मेशन होती है, it splits into two different phases and they have some different compositions, right? So this is an intermediate phase that show a very strict composition. अगर थोड़ा सा भी इधर उधर होंगे, so there will be a change. And this kind of compound, we may call it a line compound. वो जो मैंने intermediate phases आपको दिखाए थे, with reference to the Gibbs free energy change. So you can see that is almost a line, not even a range. So look at this again. अगर आप इस डायग्राम को देखें, can we split this into two parts? Okay, look at it without a line, it's a single diagram. Now, if I draw a line here, do you see that there are two diagrams, two phase diagrams that are placed along each other, is side by side? ऐसा ही है,
यस सर।
ठीक है? So this one between magnesium and this compound Mg2Pb. So this is a diagram between magnesium and Mg2Pb, and this one is between lead and Mg2Pb. So because this has a fixed composition. So two diagrams. अच्छा, इसको देख के आपको और क्या चीज ज़हन में आती है? What kind of diagram? Those who are from the background of materials, our new students, by looking at these two diagrams, which diagram, which commonly used diagram comes into your mind? Where we have that's a diagram between a compound and a pure element.
आयरन कार्बन।
Iron carbon. It's iron and iron carbide diagram, right? So iron carbide having a fixed composition. The diagram is not exactly like this, but it's between a compound and iron, right? So we can say, okay, we can split it into two, that are put together back by back, side by side. So that makes certain things easier. Okay, so phase diagrams, they also exist in ceramics. Like if you look at this one, it's a isomorphous type of diagram, soluble in liquid and soluble in solid. So liquid plus solid solution. So alumina and chromium, they are soluble under equilibrium condition. Similarly, if you look at this diagram, this is a bit different. This is between magnesium oxide and alumina. So you can see some other, this is a eutectic here, a eutectic here. Okay. So this is not a eutectic, it's not a straight line. Like this composition melts at one temperature, but this is a solid solution that forms over here. अगर eutectic होगा तो solid solution तो नहीं बनेगा ना, right? So we have a eutectic here, and this is this as a eutectic, and this as a eutectic, and similarly, like other magnesium oxide plus liquid and magnesium oxide plus, sorry, alumina plus liquid. So it's between alumina and magnesium oxide. So we can draw some similar diagrams in ceramics as well. So coming to iron carbon system. If you look at this is copper. Copper melts at 1083, so solid at equilibrium melting point, it turns into liquid. So इसमें कौन सी phase transformation is that involving a phase transformation? Is there any phase transformation?
Yes, sir.
What is the transformation in this case?
From solid to liquid.
Solid to liquid. Now, iron from room temperature.
Sir, your
So
voice
how
is
many
breaking, sir.
transformations happen in iron? Okay, so iron goes to liquid.
Yes, sir.
So how many phase transformations it undergo?
3, sir.
Okay, so it undergoes three transformations: ferrite to austenite, happening at
Two.
912, then austenite to again ferrite, happening at higher temperature, 1394, then at 1538, this ferrite again melts to liquid.
Yes,
So
sir.
involve these transformation, and these are allotropes of iron. Okay, austenite called
Yes.
gamma, ferrite called delta, this is alpha. Now we look at this iron carbon phase diagram. It's actually iron carbide phase diagram, right? Because we are drawing it between with iron and iron carbide. So अगर iron carbon diagram होगी वो भी more or less same होगी with only slight changes in composition and temperature. It's almost the same. Okay, but this is iron carbide diagram, right? So here pure gamma goes to, sorry, pure alpha iron goes to gamma and then goes to delta, and then delta transforms into liquid, right? So we have a eutectoid here. Eutectoid क्या क्या बनता है सर? What happens at eutectoid? If you are cooling from higher temperature, let's say you are cooling from gamma austenite to room temperature or to below this eutectoid,
Sir, ferrite.
two solids. ठीक है? And eutectic liquid converting into two solids. Okay, and there is a pari solid. This is a paritectic reaction here. Okay, so the maximum content of carbon in iron carbide is 6.67% carbon. So the other uh, compositions like maximum carbon that can be dissolved is in austenite phase, and it's about at this temperature. I think it's 1140. Yeah, it's 1147 degrees, and the content of carbon that is dissolved is 2.14% carbon, right? So BCC alpha having very low solubility with the maximum at this point relatively higher, while at room temperature, this amount is even less. यहाँ पे कितनी है? 0.022. ठीक है? This is at 727 degrees centigrade where this tectoid reaction happens according to this diagram. कुछ में 723 भी लिखा हुआ है, so there is some minor change in temperatures. Okay, at this point, the maximum solubility of carbon in alpha is 0.0228%. रूम टेम्परेचर पे कितनी होती है? How much carbon is soluble in iron at room temperature?
It's insoluble at room temperature.
0.002 roundabout.
Not
Somebody
room.
said insoluble. So why insoluble? I mean, if that is insoluble, you can just write pure iron. Why we write alpha solid solution? So the solubility is very very low. 0.0006 or 0.0008. Very low of carbon. Okay, I'm audible. I'm audible.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
Yes.
Okay, then there is a eutectic reaction. Okay. Then there is a eutectic reaction that happens at about 4.3% carbon and temperature is 1147. So the phases that form from liquid, they are gamma and iron carbide, right? So gamma, this gamma at the 727 transforms into alpha plus iron carbide. So forms because of the eutectoid reaction. ठीक है, क्लियर हो रहा है? बाकी आप टाइलाइन लगाएं, you can find the relative amount of phases over here or somewhere here. यहाँ पे लगा सकते हैं and you can find out the compositions as well. ठीक है? So this part, okay, up to say 2.14. अगर इस डायग्राम को हम ये दो पार्ट्स में डिवाइड कर लें इस तरह, so this range is important in terms of steels, while this part is important in terms of cast irons. Cast irons में क्या है? Higher amount of carbon, while steels they have lower amount of carbon. So say theoretically, steels can exist up to 2% carbon or 2.14% carbon, but in actual situations, the maximum carbon that the steel that is normally that is produced, but not very common, is up to 1.4% carbon. आपको हाई कार्बन स्टील्स मिल जाएंगे 1%, 1.1, 1.2%. So 1.4% carbon steels, they are also produced, but for some special applications. So while for cast irons, we have carbon ranging from say above 2% up to 4.5% carbon. Okay. So this is the range for steel and this is the range for cast iron. Okay, इस सेशन का टाइम फिनिश हो रहा है. I'll schedule another meeting in 5 minutes. तो हम 5 मिनट बाद जो है वो दोबारा स्टार्ट करते हैं. ठीक है, फ्रॉम द सेम आयरन कार्बन डायग्राम. ओके, मैं आपको लिंक दोबारा सेंड करता हूँ.
Okay, sir.
Okay, sir.
ठीक है. ओके. है